So I have us starting off right now looking at Schoology because I want you to know about a couple of resources. And I'm videotaping, so I'm putting this on. So if you want to come back, wait, what did she say? I will post the video from today's conversations. When you're on Schoology, these basically come down to your last assignments. The last thing you will turn in to me on the day you take your final is this final review. And that's the packet you picked up last time that I just gave to Lila and that I just gave to Cadence. While you're taking your final, I'm going to quick read it, give you credit for it, and then give it back to you because it's going to be a critical part of what we talked about a geometry review, a resource so that when you go back to looking at and reviewing and remembering geometry in a couple years for your SAT, then that's going to be at the front of your brain and your ability to review easier. So this is the last thing that I'm collecting from you. I'm not collecting the transformations packet. I'm not collecting the constructions packet, just this final review notes packet. When you look at this final review notes packet, there's two, for here it's divided up into two files. The one notes is after you go through, read out, clean out your notebook, and condense your notes and big ideas. That's what we're looking for, and that's the front of each of these pages. On the back of each of the pages is a multiple choice portion, and then here's the key to what the answers are, so you can go back and see. I also printed up little half sheets of the key, so and they're up there by the basket. So if you would like one of those half sheets, feel free to pick one up, or if you're like, no, I'll just check it out on Schoology, that's up to you. Questions about this last final packet that you're working on? Are we good? Okay. So that is under here as an assignment for you under your Schoology listing of things to do. Okay. Going back to our class, I also had this asynchronous graduation day assignment. So for yesterday, you didn't have your red day classes. So this is what I posted, and this is a practice final exam. I'll add the key to this assignment by the end of the day. This is optional. This is just if you want more practice. It's a sample from an older final from years ago, but it's a lot of good geometry still. So if you want to look at it and get an idea, then you can go ahead. Not required, 100% optional. Sound okay? All right. Today what we're going to be talking about is this sheet here. So lots of kids keep asking, what's on our final, how many questions, how many, and I always, I try not to be rude when I answer back, but I don't understand why the number of questions matters. I could tell you, and I've been making up numbers. I'm like 30, 52, 104, 12. I could answer anything, but it's the same thing that you've had all year. We're targeting a final taking up. You have a 2-hour block to do it. Our target is that the test is anywhere from an hour to 90 minutes. So 60 to 90 minutes is what we're planning. So for the kids that take longer to do it, you might need the full 2-hour block. For the kids that finish earlier, then you might finish earlier. So whether there are 20 or 40 or 60 questions on it, it's that that we aim for. That being said, I wanted to let you know that the first part of the final will be a short answer part. And the short answer questions will come exactly from the piece of paper you're holding in front of you. So if you know how to do these, then you're in good shape for that short answer portion. Turn to your partner and retell them what I just told you. Go. Did you know what to tell her? I saw no conversation here.
Are we gonna get the table test back, or are you just gonna put it in this?
I'm just gonna put it in this.
I got it. That was my question.
Name something that I can clarify for you. Is it important that we know how to do this paper? Yes? We suddenly now have a ramped up level of importance, immediacy, attention. How come? Say it out loud. Because, finish the sentence.
The first part of the final is gonna be on this.
So what we're gonna do is just hunt and peck and pick and take. And they're not guaranteed to be exactly the same. Mr. Logan thinks they are. We'll see who wins that argument. I thought we should change some numbers on the problems on the back. We'll get to that in a minute. But basically, when you're talking about a short answer part, this is what we're talking about. So we're going to go through this together. My request for you is that you go through it with integrity. And what I mean is, you go through it, trying it first, and then getting the feedback. Don't do that thing you do where you wait for me to do all the answers. You know how you're like, no, I'm just going to wait for her. And I had somebody tell me why they do that. I know some of you are like, I don't get it, so I'm going to wait and just copy your work, which is one reason. But one of the students is like, I think I know how, but I'm not sure, and I hate messy papers. So I always wait till you start because I don't want to write anything down and then have to erase or scribble it out if I'm wrong. I was like, okay, that's ridiculous. So let me be clear. I want you to write. I want you to put pencil paper. I want you to do the work first. And if you ever get stressed out because your paper's too messy, get a new piece of paper. Okay? So we're not about perfection here. You can go ahead and write and rewrite and cross it off and start over. Not a problem. Sound okay? That being said, will you and your partner jump in and have conversations about these triangles on the first? You have 8 triangles I want you to do. The first thing I'm going to say is know your mode. And if you don't know what I mean by that, ask your partner, what does she mean by know your mode? So I'm going to give you about 10 minutes to work, getting as much done as you can independently. You work, you learn more when you do first. So get busy, go. Let's go ahead and talk about these together. Keep in mind, anything that I do that you're unsure of, it's on you to ask. If you're like, if now, this is the time to be like, wait, how'd you get that? Or wait, why is that? Tell me more. All right. All of these theorems start off with if an altitude is drawn to the hypotenuse of a right triangle. So these theorems only work if this is a right triangle and the altitude is drawn to the hypotenuse. Every single time we talk about these theorems, that sentence comes first. If an altitude is drawn to the hypotenuse of a right triangle, then this altitude is a geometric mean between the 2 segments of the hypotenuse. So I know 3 is to y as y is to 5. This is the one that we call the loop. So when I go to solve this, I know y squared is equal to 15. So I know y is equal to the square root of 15. 15 has 2 factors, 3 and 5. Neither of them are perfect squares. Neither of them are double factors. So I can't simplify that anymore. That's it for that. Sound okay? All right. The other theorems involving if an altitude is drawn to the hypotenuse of a right triangle, each leg of the triangle, and we talked about a small, medium, large triangle, we're talking about the large triangle. this leg of the large triangle is the geometric mean between this piece that is touching and the hole. So some people like to do this loop-the-loop. So I know that x is the geometric mean between this piece that it's touching and this whole length, which is 8. So I know that x squared is equal to 40, x is equal to the square root of 40. Now 40 has 4 as a factor, so I know that's going to come out. The square root of 4 is 2, and that's leaving us with 10 left behind. Here's how you can score this. Pretend like this problem is worth 4 points. Set up, final answer, set up, final answer. If I were to grade this, this would be worth 4 points. How many points did you get? Set up, final answer, go ahead, you tally it up because you're going to see your score at the end of what we're doing. Now, if you copied my work, you just got an A. Woohoo! Shame that doesn't count for next week. So you have to do this work first. Otherwise, how will you know the difference between what you know and what you don't know? Next up, in a 45-45-90 isosceles right triangle, I know that my two legs will have the same value. And I know that the hypotenuse is going to be equal to the length of the leg times the square root of 2. So if you want to take some notes so that you don't forget how to do this, maybe you tell yourself that it's x, x, and x times the square root of 2. The harder ones for these are where if you're given the hypotenuse and you have to set it equal to x times the square root of 2 and then solve for that, when your unknowns are the leg and the hypotenuse, those are easier. Consider this worth 2 points, one for each answer. How many points did you get? This problem was the most missed on your test. It's similar right triangles, and you can't use the side splitter theorem because this x is not on a side with the 48. The side splitter theorem applies to these pieces of the triangles, but you'll notice the green is just a piece, not a whole. So if you wanted to set up the side splitter theorem, you could set up the relationship between A and B and 30 and 50, but that's not this problem. This problem set up is talking about solving for this x. So 30 and x have a relationship that's mirrored by 80 and 48. This side length here is 80 when I add together 50 and 30. Now, some people don't see the proportion that way. That's fine. If you would rather set up the proportion that says 30 is to 80, this corresponding side is to this whole side, as x is to 48, that is also a true proportion. Notice I just switched my means. Notice x and 80 just switched places. When I go to solve this, I'm still saying 30 times x, no, 80 times x is going to be equal to 30 times 48. Some quick calculator work. 48 times 30 divided by 80 is going to give me x has a value of 18. Give yourself 2 points for this one for the setup, one for solving the proportion. How are we doing so far? Here I have a 30, 60, 90 triangle. When I talk about 30, 60, 90 triangles, I talk about this being x, this being 2x, and this being x times the square root of 3. Make sure you know your short leg is always opposite of the 30-degree angle. Don't go by the picture, go by the numerical values that are given to you. With those relationships, I know that then y is going to be equal to 16 and x is going to be equal to 8 roots of 3. 2 points for that one. How are you doing? 1 for each one. All right. Next up comes solving the right triangle. When we're solving the right triangle, we need to make sure that means 6 pieces of information. 6 items. So when I talk about the measure of my angles versus the lengths of my sides, on any given triangle, I'm already given at least 3 pieces of this information. And the number 1 is going to be that I have this 90-degree angle. Now, obviously, this is difficult to do because we haven't named it. So let's go ahead and name it triangle A, put B at the top, and C over here. So 90 degrees is the measure of angle A. 38 degrees is equal to the measure of angle B. And how do I find C? Yeah, so they're going to be complementary. So 30 plus something is going to be equal to 90, or I can add them all together. 38 plus 90, and then subtract that from 180. I get a 52-degree angle for the measure of angle C. I need 3 sides. I need to know the distance from A to B. I need to know the distance from B to C. And I need to know the distance from A to C. One of those I have. 2 the more I need to find. I'm going to do X or Y first. X I heard. Do we want to use angle B or angle C? B. Always go with what you're given just in case you screwed that up. Right? Okay. Because wouldn't it be terrible to have clumsy thumbsies? Mess up on this and then mess up on that instead. All right. So I'm looking for X. I have 14. Is that a sine, a cosine, or tangent conversation? Yeah, so the tangent of 38, that ratio between, for those angles, my side opposite, which is what I'm looking for, my adjacent, which is what I have. When I put this over 1, my measurement for length x is going to be the tangent of 38 times 14. Here we go to the calculator. Ready? I'm going to go to mode, and I'm going to make sure I'm in degrees. Good news there. And I'm going to ask the calculator, hey, can you tell me what the tangent of a 38-degree angle is? And then I'm going to multiply it by 14. And I get 10.94. The distance from A to C is 10.94. We okay? All right, now let's talk about Y. That's X. Now, when it comes to Y, you have 2 choices. You can do your trig and use a different trig ratio if you want, or you can do Pythagoras. Both of those will give you the right answer. What do you want to do? trig I heard, okay? So I have my 38-degree angle. I'm going to use 14. So which trig ratio am I using? The cosine of 38 is going to be equal to my side adjacent over my hypotenuse. So that means that 14 is equal to my cosine of 38 times x. So I'm going to divide each side by the cosine of 38. And that'll give me my x. So I'm going to go to my calculator. All right, here's 14 divided by the cosine of 38. 17.77. Solving the triangle means 6 pieces of information. Are you ready for the best part of the story? This one's worth 6. What? 3 freebies. Isn't that nice when you go to solve a triangle? You get 3 freebies. Do you know that lots of kids will get that wrong because they won't bother to write them down? Unbelievable. Number 6 represents the one thing that everybody always forgets, and that is your angle bisector theorem. And that is the fact that if this angle is bisected, which it is, it's going to divide this opposite side proportionally. It has nothing to do with right triangles, nothing to do with similar triangles. I just know that 5 compared to x is going to be the same as 8 compared to, don't say 7, because 7 is that whole, so it'll be 7 minus x. Hey, bubble wrap that, because we want to make sure that when we do some math here, 8x is equal to 35 minus 5x. We have to make sure that when we do that cross products, we're distributing that 5. Adding 5 to each side gives us 13x is equal to 35. So then x is equal to 35/13. That doesn't divide out evenly. It's not a pretty number. 13's prime. 35 is just 5s and 7s. So I'm not going to be able to simplify it. I'm not going to be able, and don't give it to me as a decimal. If you give me an answer like that as a decimal, I'm going to take points off, because as soon as you stop writing digits, it's not the right value anymore. It's a compromised value. So you leave it as 35/13. Got it? 2 points for this one. Did you set it up correctly? And am I happy with how you left the answer? How are we doing so far? I'm going to stop talking, and I'm going to give you a couple minutes to go back. And if you need to do more work and solve these 2 triangles, I'm going to let you go. And we'll come back in 5 minutes when your mark is at work. All right, let's go see how you did. Rule of thumb, if you're given 2 sides of the triangle, solve the third side by doing Pythagoras. Anybody have an idea of why? What do you think, Cece? Okay, so if you solve for one of the angles incorrectly, then you're messed up. That's very true. How many times have you figured out what that trig ratio is, and it's been a number like 1/2 or 1? Very few times, right? When we figure out what a ratio is, isn't it normally what, like this, digits that go throughout the end of the calculator and we end up rounding? So the minute that we start relying on trig, we're potentially compromising, because remember, we're taking those radians and putting them into degrees. So we end up estimating, so we lose our true value. If you want to solve these and not lose any of your measures, what you need to do is use Pythagoras to find the side that you're missing. All right, let's talk about what we have. The measure of angle M is my 90-degree angle. I'm going to have to find the measure of angle E. I'm going to have to find the measure of angle U. When I talk about my sides, my distance from U to E is 28. My distance from E to M is equal to 19. And my distance from U to M, I'm going to go ahead and solve by using Pythagoras. My hypotenuse is the side that's opposite of my right angle. So 28 squared is going to be equal to b squared plus 19 squared. I'm going to go to the calculator, and I know that 28 squared is equal to 784, and I'm going to be subtracting 19 squared from it, giving me 423. So 423 is equal to b squared, square root, second radical, second answer. Doesn't come out evenly. So now I got to look at whether or not 423, it can be simplified as a radical. So b is equal to the square root of 423. I look at these numbers and I go through my divisibility clues from elementary school. It's not even, so it can't be divided by 2. Doesn't end in a 5, so it can't be divided by 5. If I add 4 plus 2, I get 6. 6 plus 3 is 9. Oh, what evenly goes into it? If the sum of the digits is divisible by 3, that means that 3 evenly goes into that number. So 423 divided by 3, let's see if we get a number we like better. Ooh, 141. What's 141 divisible by?
3.
4 plus 1 is 5. 5 plus 1 is 6. Ah, let's try taking another 3 out. 47. 47 is where it stops, right? 47's back down in our friendly numbers. 47's prime. But do you see how I have 2 factors of 3? That means that I can take the square root of that, and I ended up with 3 roots of 47. Now I got to do some angle work. What do you want to do first? U or E? E, I heard. All right. What side am I not going to be using in my calculations? Yeah, I'm not going to use that radical one. No thanks. So if I want to know the angle whose measure, I have my hypotenuse and my adjacent. Which trig ratio is that? That's going to be cosine. So the cosine of my angle is going to be equal to the ratio of my adjacent compared to my hypotenuse. So the cosine of theta is going to be equal to my adjacent, which is 19, compared to my hypotenuse, which is 28. So I'm going to take the inverse. I would like the angle whose cosine is 19/28. Here we go with the calculator. Ready? Because I'm looking for the inverse, I need to use this function here that's above my cosine. So I'm going to use the blue button. The angle whose cosine is 19 divided by 28. And the calculator is going to tell me, oh, that's a 47.27 degree angle. We're going to go ahead and leave that as 47 degrees. Oh, that was E, wasn't it? So the measure of angle E is 47 degrees. Here's my trick. 90 minus this is going to be a 43-degree angle. So I know that those two angles have to be complementary. So I'm okay with my rounding. Angles to the nearest whole, side lengths, if you're using trig, to the nearest hundredth, Pythagoras to the nearest, and simplify the radical. 6 points. How'd you do? Give yourself a score. All right, we're going to go back to this one. And I've got my 3 angles. I'm running out of space here. So I've got angle Q is equal to 90 degrees. Angle N I need to work on, and angle P I need to work on. The distance from Q to N is equal to 18. The distance from Q to P is equal to 11. And the distance from N to P I need to work on. 11 squared plus 18 squared is equal to C squared. Calculator, 11 squared plus 18 squared, 445. Second radical, second answer, rats. So I know that my C is going to be equal to the square root of 445. What do you want to do to try to break that down? Divide by 5. It's a good call. 89. Huh. Sebastian's shaking his head. The 2 doesn't go into it. 8 plus 9 is 17. 3 doesn't go into it. If 2 doesn't go and 4 doesn't go, 5 doesn't go. If 3 and 2 don't go, 6 doesn't go. 7's my only option so far. Does 7 go into 89? Negative. 8 doesn't go, 9 doesn't go, 10 doesn't go. I think we're going to leave it be prime, right? What do you think? So we can just say that C is that this side length here, the distance from N to P, is the square root of 445. All right, it's time to find some angles. You want to do N or P first? Call it out. N, I heard. All right. I can't use my hypotenuse because that's a nasty number. So what am I going to use? Which trig function does not involve your hypotenuse? Tangent. So the tangent of N, my angle theta, is going to be equal to my opposite compared to my adjacent. So I know that the tangent of my angle is going to be equal to the opposite is 11 and the adjacent is 18. So into the calculator I type the inverse tangent of 11/18. Ready? Inverse tangent of 11/18. A 31-degree angle. So N is 31 degrees. Here's something interesting. If you had chosen P, what switches is which side's opposite and which side's adjacent. So we can real quickly say inverse tangent of 18 divided by 11. Notice that gives me my 59-degree angle. So whether I get my 59 degrees from the triangle sum theorem or just doing the trig again, no big deal. That's another 6 points. Would you please tally up how many points you got out of 18, 20, 2, 4, 6. Oh, that's 30 points. What you get? right, these next formulas should be at the front of your brain and memorized without fail. And however you choose to make sure that you understand how they go, and there's some wiggle room and some flexibility with how you represent these. For example, if you do y1 minus y2 and x1 minus x2, no one cares, as long as you make sure you do it in the same order. Because it's a change in your y's compared to your change in x's, and nobody cares what coordinate pair you call 1 or 2. So if you mix it up, just mix it up on both. Got it? Our midpoint formula is the average of the x's and the average of the y's. Our distance formula comes from Pythagoras. So we're hoping that from this one you can see c squared is equal to a squared plus b squared, where that difference between your x's and that difference between your y's is the horizontal and vertical leg of a right triangle. And that c is going to be my hypotenuse. Some notes that I want to make sure that you take is it doesn't matter if you are consistent with which is 1, which is 2, because when you square it, you're going to square away the negatives. You should never, ever, 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 ever get a negative value. Never. So lots of people screw that up. Because if you type into your calculator, let's say that you're typing -4 squared. Let's say you type that in, you will get a negative. And the kids are like, see, I get a negative. But what you just asked the calculator to do is -1 times 4 squared. That's what the calculator heard you say. If you want the quantity of -4 squared, that's always going to be positive. So your choices are just to ignore the negatives, because you're never going to have the outcome of a square be negative. You okay with that? All right. Take a minute and completely pull from the back of your brain, when are we using slope? When are we using midpoint? When are we using distance? Go ahead back. When are those a justification? Take a minute, talk with your partner, go. When we're talking slope, we're talking parallel versus perpendicular. So parallel lines have the same slope. Perpendicular lines, what are the slopes? Opposite reciprocals. If the two lines are perpendicular, they're opposite reciprocals. So basically, anytime we're trying to prove something's perpendicular, why would we care if something's perpendicular? I can think of a couple big reasons. When do you need to know if something's perpendicular? Okay, let's talk more. What shapes have perpendicular things? Squares. Squares have perpendicular what? Perpendicular what? Sides. Go on. What else? What else is perpendicular in squares? What else? What else? Yeah, diagonals. So if you're trying to prove a square or a rhombus, perpendicular diagonals. If you're trying to prove a square or a rectangle, perpendicular sides. What about a right triangle? Is a right triangle going to do it for you? Perpendicular? Heck yeah, right? So anytime you're trying to prove some kind of shape, off you go. Talk with us when you come back. So when we talk about each of these formulas, what they add to our knowledge is a justification, and that's all part of what comes next, which is proving, right? So if you say this is a square, someone has to be like, well, how do you know? Oh, I know because the sides are perpendicular and the diagonals are bisected and the distance of each side is the same, right? So whatever you need to prove about whatever shape you're talking about, these big three are your justifications. So how do you know that's true? I round the numbers. I round the numbers. Midpoint's this. I round the numbers. And the slopes are this. I round the numbers and the distance is that. So these three formulas, slope, midpoint, and distance, are going to be the justifications that we use in what we're doing next. All right, so a couple things. What a difference it makes when you use a straight edge. Because the shape might appear to be something, but not necessarily. So what I want you to do is double check your shapes with me right now. Make sure you're in the right quadrant. And we can probably make pretty good guesses about what these shapes might be. But here's the deal. 9 months ago, you would have been able to say, oh, that's a whatever. But now you can back up what you might say. Square, parallelogram, trapezoid, isosceles, acute, right triangle. Now you can back it up with some math. So even though the shape name is the next line, I'm not filling that in until I'm sure. And I'm not going to be sure until I do some math. So it's looking like this is some kind of quadrilateral. I'm thinking parallelogram. Could be a rhombus. Could be a rectangle. If it's both of those things, then it's a square. So basically what I'm out to do is prove that it is a square. You guys want to join me? We're on the other side of the paper. Okay. There we go. So what I want you to think carefully about is not just what it is, but what is it not. So I want you to think about that hierarchy of shapes that we have, those terms that we have. We can talk about whether or not it's a parallelogram. We can go ahead and prove that those two opposite sides are parallel, and that definitely rules out trapezoid. But then how do we rule out the fact that it's not a rectangle? Or is it a rectangle? How do we rule out the fact that it's not this or that? The more in-depth you are with your answers, the better you get. Turn and talk to your partner and talk about a plan for what you can say this shape is unequivocally. Go. Do. What can we do? Because we want to be smart about how we do this, right? What would be the best thing to do right away? What do you want to do? What do you want to do? Go ahead. Find the slope of what? Okay. So right away, and by the way, if life gives you a coordinate plane, use it. You're allowed to use it. So the slope of BC is rise, 1, 2, 3, 4, 5, run, negative 1, 2, 3. So the slope of BC is equal to negative 5/3. The slope of, and if I'm trying to prove parallel, I'm going to do AD next. AD, 1, 2, 3, 4, 5, negative 1, 2, 3. Awesome. So those are the same. So I'm going to go ahead and give myself some notes. AC, there you go. Or that's AD. Awesome. They're both the same. They have that same slope. Now let's talk about the slope of segment BA. Rise 1, 2, 3, run 1, 2, 3, 4, 5. Oh, it's looking good. And the slope of DC, rise 1, 2, 3, run 1, 2, 3, 4, 5. That's going to be the same as the slope of DC. So here's what I'm looking for when I go to grade this. You can say, therefore, 2 sets of opposite parallel sides and 2 sets of perpendicular sides. Or maybe instead of 2 sets, we should say all. How should we phrase this? How do we know that they're perpendicular? We'll call them consecutive sides. Consecutive sides are perpendicular because slopes are opposite. Okay. So I've got, therefore, two sets of opposite sides that are parallel. So I know it's a parallelogram, right? Consecutive sides are perpendicular because the opposite sides are reciprocals. Therefore, it's a rectangle. What else could I do? Because we all know it's not a rectangle. What's going to make it a square? That maybe either the side lengths, the distance of my sides. Anything else? Yeah, what's that going to do? You're right. It's going to prove it's a what? What else has perpendicular diagonals? Yeah. 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 It's, if I can prove it's a rectangle and a rhombus, isn't it a square? Right? You with me there? Okay. So here I have it being a parallelogram. Here I have it being a rectangle. So am I allowed to go ahead and just draw diagonals? Can I do that? Ariane says yes, everybody. He gives us permission. So let's go ahead and say the slope of AC, rise 1, 2, run 1, 2, 3, 4, 5, 6, 7, 8, negative, right? Rise 2, run negative 8, that's negative 1/4. Oh, I'm hoping that the slope of diagonal BD is what? What am I hoping for? Opposite reciprocal, which is what? 1, 2, 3, 4, 1. 1, 2, 3, 4, 1. Yes. Therefore, rhombus. Would you please, right now, with your partner, write a conclusion? How many of you had this on your paper? How many of you had conclusion on your paper and you lost a point on our polygon test? Yeah, don't lose that point. So write yourself a conclusion right here. Therefore, and this is where you tie it all together. This is just your calculus, like this is just your notes. This isn't full sentences. This is just, I did these calculations, I did this on a thing, and I have these, therefore I have these ideas. Now it comes time for you to put it all together and tell me what is the name of that shape. We're confident it's a square. Now tell me why. Work with your partner, go. Therefore, ABCD is a square because. Tell me what we did. Because it has, go ahead,
Two sets of opposite parallel sides.
which make it a.
Parallelogram.
It also has
Perpendicular diagonal.
perpendicular, we did, yes, perpendicular diagonals, which makes it a rhombus. I think that's enough, because there's no parallelograms, there's no other parallelograms with perpendicular diagonals, is there? Oh, yeah, there is, it's a rhombus. We need to know this middle part too. What else is it? You're so on the hot seat. Yeah, keep going. Therefore, it's a,
Rectangle.
because it has
Consecutive sides.
perpendicular, right? It has 4 right angles. So it's 4 right angles, therefore it's a rectangle. It has perpendicular diagonals, therefore it's a rhombus. It has 2 sets of opposite parallel sides, therefore it's a parallelogram. Go for smarty up, thinking question. Okay? So you need to list each of those things in your answer. Make sense? All right. This next example is the example of something in the negative. And what I mean by negative is the fact that this shape is a whole lot of nothing. I'm going to give it away. This shape is a quadrilateral. And this is why you could say it's a quadrilateral because it has 4 sides. I know it's not a parallelogram because the sides are not parallel. It doesn't have 2 sets of opposite sides. I know it's not a trapezoid because it doesn't have 1 set of parallel sides. So you tell me, once you tell me it's not a parallelogram, that just rules out square and rectangle and rhombus, right? So all you gotta do is tell me it's not a parallelogram. Once you tell me it's not that, I know it's not any of those. Okay, it's not a trapezoid because it doesn't even have 1 set of parallel sides. You could say it has no sets of parallel sides, therefore it's neither a parallelogram or a trapezoid. Do the diagonals. It's not a kite, doesn't have perpendicular diagonals. It's not a kite because it doesn't have consecutive congruent sides. So once you rule out those 3 big areas, and do you remember what those 3 big areas are? Do you remember what those 3 big areas are in our parallelogram or a quadrilateral? When you're talking about what things are, so if I have the shape, if I have the set of all polygons, within that conversation, I have my quadrilaterals. Within that conversation, I have my parallelograms. And within that conversation, I have my rectangles. And then I have my rhombuses, right? And then we all know what's in here. You okay with that? Within quadrilaterals, I also have my trapezoids. I also have my kites. And we can talk about a convex shape if it's my darts. Don't forget I'm not putting darts on fire. But guess what? Within that, we also have our triangles. And then we have our acute right and obtuse triangles. So if I have an acute and a right and obtuse triangle, within that I also have our isosceles equilateral, right? So they all fit together in different ways. So these are what we're going to be talking about. So if it's just a polygon, you're definitely going to be able to tell me about how many sides it has. Definitely at least a quadrilateral or a triangle. You can tell our third one's triangle, only 3 coordinates. So we got that. So when we get to that third one, you're going to have to tell me, is it acute, right, or obtuse? Is it isosceles, scalene, or equilateral? So classify the triangles by name and sides, and classify this. So this conversation comes from what it's not. It's not a parallelogram. I can disqualify rectangles, squares, and rhombi just by proving it's not a parallelogram. Okay, it's not a parallelogram. Is it a trapezoid? No, because it doesn't have anything parallel. Is it a kite? Yeah, no. It doesn't have congruent consecutive sides, and it doesn't have perpendicular diagonals. None of that stuff exists, so no. All right, when we take a look at this one, what is the name of the shape? It's triangle, but what kind is it? It's isosceles, and Philip, we know it's isosceles because it looks isosceles, but what if I needed to prove it was isosceles?
Distance of the light.
Say that again?
Distance of like BC. and
Yeah, I'm going to use the Pythagorean converse. Remember that Pythagorean inequality? If c squared is bigger than a squared plus b squared, then it's going to be a obtuse triangle. So I can get angle measure from the Pythagorean converse. How do I know if it's if it's isosceles or equilateral? How do I know that? Distance. Sure. So for this one, if I wanted to say it's an obtuse, isosceles. If I want to get to it being an obtuse isosceles triangle, I'm going to have to prove the distance from A to B. I'm going to have to prove the distance from B to C. I'm going to have to go ahead and find the distance from A to C. I'm going to have to use my Pythagorean converse. And I'm going to have to, that's going to give me my angle measure. And these distances are going to give me my classification by sides. Don't forget, you have this final statement down here that says therefore. This final statement down here that says therefore A, B, C, D is a quadrilateral, and you would say here because it is not, and then you talk about things as a negation. Take a minute and practice writing that. Take a minute and do those calculations. Take a minute and make sure that if this were a test, you'd earned all the points. Go. Here are the slopes of the four sides. No sides are parallel, so it's not a parallelogram, it's not a trapezoid. Here's the slopes of the diagonals. It's not a kite because the diagonals are not perpendicular. So therefore, ABCD is a quadrilateral because it's not, because it has four sides and not any of the other specific shapes. Make sense? All right, I'll see you next Monday.
What is this for?
Those are